Hi guys, welcome back to my channel. So in this video, I'll be taking you through reduction formula. In our previous lesson, we did one part of the reduction formula, which for the integration by parts, integral of x to the power n e to the power x. So we continue in this section with the reduction formula for tan nx. Okay, tan to the power n x dx. So if you want to find the integral of tan to the power n, it can be tan 5, tan to the power 5, it can be tan to the power 6, tan to the power 7. So irrespective of the power, we have a pattern of the integration, and that has been summarized in our reduction formula, which we are going to talk about. So before we start, we have the proof of the reduction formula here, and I also have a problem here for us to solve using the reduction formula here. Right? So we say that assuming that you have un, right, u sub n to be equal to integral of tan to the power n x x, right? So this is going to be any general or any arbitrary integral for tan to the power n x, provided that our n is greater than 1, greater than or equal to 1. That is the condition. Provided that our n is greater than or equal to 1. You know that if n is 0, there's no point in doing what you're doing, right? So provided that n is greater than or equal to 1, then here we are using our simplification here to see what they did here. We are saying that whenever you have integral of tan to the power nx, it's always equal to, they only subtracted 2 here and they brought 2 here, right? So they were trying to extract tan to the power 2x out of this tan nx, right? And once you subtract 2 from it, the resultant becomes n minus 2. This because we don't know what is here, we don't know n, right? So once you subtract 2 from it, we get external tan squared x, then also get tan to the power n minus 2, right? Yeah. So from this section, we came to this side. We maintain the tan to the power n minus 2x. Then for the tan to the power 2x, that's the tan squared x, what you do is assume that there is plus 1 minus 1. This is nothing. These are some kind of modification we do in mathematics so that we can get or find our way ahead, right? So 1 minus 1, we all know that is 0. But once you bring 1 minus 1 here, it's going to have an effect here. So how does it have effect here? So realize that tan squared x plus 1, which was, broken here. So see from this section, what you do is you expand this. Okay, from this section, you only have to expand this section. So upon expansion, you have tan to the power n minus 2x multiplying what? Tan squared x plus 1 separately. Then the minus 1, 2 will have minus tan of what? N minus 2x dx. Is that not it? And at this point, you realize that this whole expression, when you have tan squared x plus 1, is the same as sec squared x. Is that not it? Squared x, and you realize that this is the derivative of what? Tan squared x is the derivative of, so we are trying to, so it's the derivative of what? Tan x. You know that the derivative of tan x is giving us what? It's a squared x, right? Tan x is giving us a squared x, and you also know that 1 plus tan squared is the same as what? It's a squared. So that is what you're able to derive after doing this manipulation 1 minus 1. Okay. After doing this manipulation 1 minus 1. So from this section, we came to the conclusion that our entire derivative integral will give us 1 over n minus 1 times to the power n minus 1. So this side was maintained, was not touched, right? This side was not touched. Yeah, this side was not touched. So we you realize that this side, if you affect the integral to it, I think you're gonna get if you're having a derivative of tan x, this whole thing is representing the derivative of tan x. So obviously we will get tan x as a resultant because we are taking the integral of what derivative, realize that. So and that will take one of our power here to n minus 1 because you are adding 1 to it, you surely get n minus 1. Then after doing your simple integration, you add 1 and what? you add 1 so that you have 1 over n minus 1 times the power n minus 1x. Then what you are doing is you realize that this section that we started with, that is our un, which is equal to integral tan to the power nx, is almost what you have got here, but now it's minus 2. So represent that with what? Un sub n minus 2, right? U sub n minus 2. So in all, forget about this proof, okay? Forget about this proof if I'm not really getting it. Then have this in mind that the reduction formula for tan to the power n of x is always given as 1 over n minus 1 tan to the power n minus 1x minus u sub n minus 2. Then let's solve this problem here. So it says evaluate the integral of tan to the power 5x. Evaluate the integral of tan to the power 5 of x. So we come to the reduction formula here. Come to the reduction formula here, which you know that is 1 over n minus 1. 1 over n minus 1. So since our n is 5 here, we simply have our u5, right? u5 will be equal to, we only make it substitute, 1 over 5 minus 1, right? Tan to the power, so tan to the power 5 minus 1 x minus our u n minus 2 be what? u3, right? u3. Then you put it down. So right now, this is what you are looking for, our general form, right? Because you're looking now for u sub 5, because the power is 5. So this gives us 1 over 4 tan to the power 4 of x minus, now what is u3? You realize that u3 will also follow this same expression, 1 over n minus 1. So I'm going to have 1 over 3 minus 1, since you are dealing with what u3, okay? Tan to the power 3 minus 1 dx, right? Minus, now it's un minus 2. But in u3, we are going to get u3 minus 2, right? So see, I get 1 over 4 tan to the power 4x, tan to the power 4 of x minus 1 over 2. This expression I'm simplifying. Then tan to the power 2, tan to the power 2 of x, right? Tan to the power 2 of x. Or let's say tan to the power 2 of x minus u1. u1. So right now we are at u1. And what is u1? So let's see. Our u1 is simply going to be what? Having 1 just here. 1. So that one, especially our u1 is simply equal to the integral of what? Tan to the power 1. And you know tan to the power 1 is what? Tan. Yes, so tan x dx. So that is u1. So after getting this here, we know that the integral of tan x is simply what? Negative natural log of what? Cos x, right? So we're going to have u1 to give us negative natural log of the absolute of cos x, right? Then plus c. So we simply combine our u3 and u1 to u5, meaning our final integral, which is represented as u5, is equal to 1 over 4 tan to the power 4 of x minus 1 over 2, right? Tan to the power 2x. Then our u1 follows, right? Our u1 follows. So that will give us, that's going to give us, let's say, this minus u1, right? Yes. So we are going to have natural log. So this give us the derivative of the tan x is giving us negative ln cos x, right? So if we are joining into the our general, here was minus u1, so it should be plus, right? Natural log of what? Absolute of what? Plus c, right? Plus c. And this is how we apply. So the goal is just capture this in mind, right? 1 over n minus 1 times the point minus 1x minus u n minus 2. Once you have this in your mind, then I think whatever the power of tan is, you can be able to solve it. So thank you for being with me. Don't forget to like,